is up? Welcome to this challenge. So I'm going to be doing the International Baccalaureate Maths Higher Level Exam Challenge. We're going to be doing paper 1. I probably will do paper 2 and paper 3 in the future. However, we're going to be doing paper 1 for now. And basically what's going to happen is I'm going to answer all the questions from 1 through 12. There's going to be stuff in there that I don't know, like statistics, but we'll see how I do. So let's go. I think we have 1 hour to do this, so let's go. Well, at least I do have 1 hour, so find the solutions of log base 2, log 2x minus log 2 5 equal log 2 3. So first of all, you have this log base 2 of x minus log base 2 of 5. You can combine this using one of the one of the logarithmic laws into divide like this, and then you can put it it's equal to 2 plus log base 2 of 3. Now this is really inconvenient. You don't want to have 2 in here, so you can actually you want to have it kind of in terms of log base 2, or what you can also do is you can just take both things to the second power. So you can actually do it this way, where you have x over 5 equals log base 2 will give you, well, that's log base 2 equals log base 2 of something, and that's log base 2 of 4, and then you can add that to log base 2 of 3, which will give you log base 2 of 12 if you know your addition, and that'll get you x equals 60, because 60 divided by 5 is 12. Or you can also take both to the second power like this, so then you'll have 2 to the power of 2 to the power of 2 plus log base 2 of 3. Which will get you, I think, that'll just be x over 5 is equal to 2 squared times 2 log base 2 of 3, and that's going to be 4 times 3 equals x over 5, and x equals 60. So you get 60 60 no matter what, right? So that's the first question. Second question, consider complex numbers, these complex numbers right here, by expressing x's in a z1 and z2 in modulus argument form. Write down modulus of w, argument of w. So this modulus argument thing, modulus means distance from the center, and argument means degree from the center. So I'm gonna put it down both in degrees and radians just in case, but so first of all, we actually got to figure out what w is. So we're going to take this 1 over square root of 3i plus 1 minus I, and we're going to do this to both of them, right? 1 minus I, 1 minus I, and what we're going to get is 1 minus I squared, which is 2 at the bottom. And what's going to happen is we're going to have 1, and then this is going to be minus I plus square root of 3. So that's going to be plus square root of 3, because minus I squared gives you positive I, and then plus square root of 3i minus I. So that would just be plus, wait, give me a minute. Square root of 3i minus 1i. So that's plus square root of 3 minus 1, and then that's I. So this is our answer, right? This is w in a rectangular form. However, we want it in modulus argument form. So what we're going to do is we're going to get 1 over square root of 3 plus 2 plus, this is actually square root of 3 minus 1, square root of 3 minus 1 I over 2. So how do you find a modulus? First of all, to find the modulus of w, you need to square the a and the b term. So square this and square this, and then add them together. So what's going to happen is this is going to be 1 plus 3 plus 2 square root of 3, and I might actually get some of this wrong. I'm just human. So and then this is equal to, you don't square the I, so square root of 3 is 3, and then 1 is just 1, and this gives you minus 2 square root of 3. So the modulus is actually pretty nice. It simplifies to, this is 4 over 2, and then we can cross these off, and then what we'll get is 4 over 2 plus 4 over 2, which is 4. So the modulus is 4, and our argument is going to be, where's our argument? So W, I don't know the sign for argument. I'm just gonna put R of W. Our argument is going to be tangent, right? It's going to be so what we want is, we want this for this. What we want is the angle. So whatever it is, we want its angle, like this. So in order to get its angle, what we're gonna have to do is we're gonna have to see which quadrant it's in first. So which quadrant is this in? Well, first of all, we have 1 plus square root of 3 and square root of 3 minus 1. So 1 plus square root of 3 is obviously positive, and then square root of 3 minus 1 is also positive. So since they're both positive, since these are both positive, we can assume that it's going to be about right here. About right here. Right? And this question actually suggests me to put z1 and z2 in argument form first before I do all of this, which I probably should. Actually, yeah, I'm gonna do that right now. So we have our modulus right there, but we need to change it. We need to change it the argument form of it as well. So that's what I'm gonna do for right now. I don't think this is correct, actually. I'm starting to doubt myself. Let's see. I'm really starting to doubt myself. 4 over 2, 4, okay. Oh, yeah, this is not correct. This is not correct. Because after you square them, you have to take the square root. So 4 over 2 plus 4 over 2 is equal to 4. But then you have to take the square root of 4, which is equal to 2. So 2 is the correct answer. 2 is the correct modulus, not 4. Next, we do... so modulus of 1 plus square root of 3i. That's just... what I can actually do is I can take this 1 and square root of 3 right here, and I can actually divide it by square root of 3. Divide these both by square root of 3. So what I'll actually get is, this is at 1, and this is as a square root of 3 over 3, which can, I was about to say it could help me, but I don't think it's gonna help me. I don't think it's gonna help me that much, because that's not a normal fraction. You know what? I'm just gonna try to do it this way. This way seems a lot simpler. We're gonna take the inverse tangent of y over x. So y means this over 2, and then x is this. So 1 plus square root of 3 over 2. But our square root of 2 are divided by 2s, they cancel. We've got to rationalize our denominator, which will get us this, and then this is we're gonna get. Actually, no, this is wrong. Don't rationalize like this. Don't be a dumb. Just do 1 minus square root of 3, and then 1 minus square root of 3. Right, you gotta do the conjugate of the square root. This will give you 1 minus 3, which is minus 2, and then at the top will give you square root of 3 plus square root of 3, so 2 square root of 3, and then plus 1 plus square root of 3. I hope I'm not doing this wrong. I really am hoping I'm not doing this wrong. But our argument is going to be this. It's going to be tangent inverse of this monstrosity. 3 square root of 3 plus 1 over minus 2. That's a ridiculous inverse tangent. That's an absurd inverse tangent. I don't even think it's right. Let me check one more time. Minus 1 times 1, that's minus 1. Yeah, it's not right. It's not right. So, minus 1 times 1 is minus 1, so it should be minus 1 down here as well. And it should be minus square root of 3. So the correct answer is actually square root of 3 minus 1 over minus 2, or 1 minus square root of 3 over 2 tan inverse. So that's a lot more manageable. There you go. Tan inverse of 1 minus square root of 3 over 2. And if I get that wrong, so be it. Question 3. Solve the equation sec squared x plus 2 tan x equals 0. Sec squared x is equal to 1 plus tan squared x. Right, I think. And if you add that to 2 tan x equals 0, you will get tan squared x plus 2 tan x plus 1 equals 0, which is the same as x squared, or tan x plus 1 squared equals 0. So for next you have tan x plus 1 equals 0. And so tan x equals minus 1, so x will be minus pi over, no, not minus pi over 2. Tan x plus 1 is equal to 0, so tan x equal minus 1. So x is equal to 135, or 315, which is 3 pi over 4, 7 pi over 4. Those are your answers. There you go. Next, 3 girls, 4 boys are seated randomly on a straight bench. Find the probability that the girls sit together and the boys sit together. So girls have to all sit together, and the boys, they have to all sit together. Okay, so that's kind of easy. 7 factorial ways for the girls and the boys to arrange themselves. 7 factorial ways, and 3 factorial ways for the girls to kind of like shift in their own kind of area, and then 4 factorial ways for the boys to shift in their own area. Right, so you can have girl, 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 boy, 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 but girl 1, girl 2, girl 3, the order doesn't matter. You can have 7 factorial, 3 factorial, 4 factorial. So 7 choose 3, basically. This is the probability that the girls sit together or the boys sit together. However, there is an alternate case of boy, 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 girl, 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 and that would be the exact same thing. So I'm actually not sure. Let me do it with a smaller example. So B, 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 G, G right here. So if we do 120 divided by 3 factorial, 2 factorial, that'll give you 12 possible combos. But we could also have it the other way. So this is actually a 2 times 2, because you could have it both ways like this. But find the probability that the girls sit together and the boys sit together. Well, I already have this combination thing, and then I can divide that by 7 factorial. So you basically get times 1 over 7 fact. Wait, no. Yeah, I can basically divide this answer, by 7 factorial. And so whatever this answer is, it's going to be 7 factorial, 3, 4, 9, 6, 4, 288. But I'm going to do the expansion so that it's easier to calculate. 3, 4, no, 3, 2, 1, 4, 3, 2, 1, 2. 3, 2, 1, 4, 3, 2, 1, 2. Okay, so we're going to do that, and then we're going to do that, and then we're going to do that, and then we're going to do that, right? So 6 is 2 times 3. Okay, that doesn't really make sense, because, we're supposed to put the 2 on the top. I'm sorry. Supposed to put the 2 on the top. 7 factorial times 2 over 3 factorial 4 factorial, which will give you 70. and 70 divided by 5,040, which is the value of 7 factorial, is 1 over 52. I think. No, not 1 over 52, 1 over 72. And that's your answer. It should be. 1 over 72 is the answer for this question. ABCD's parallelogram where AB and AD, AB is I 2J 3K. So let's draw this coordinate plane. I don't advise if you know what you're doing, you don't need to draw a coordinate plane. I'm just trying to show you guys, I guess you could say, not how to draw a coordinate plane, but how to kind of visualize in this 3 dimensions. So I'm going to put this as the I coordinate, the J coordinate will be this, and then the K coordinate will be this. So we have I, or minus I, right, plus 2J, so say right here and right here, and then plus 3K, so 1, 2, 3. So our thing lies in space around here. And if you can't visualize that, let's say A is just in the center, right? It's a vector. Because it's a vector, it doesn't really matter where the endpoint or the beginning point is located at. This equation, this IJK kind of stuff is just it's important for like keeping track of what the magnitude or the direction of the vector is, but it's not really important for the like the actual place where the vector starts. So you could kind of draw like that if you can't visualize it, but I'm just not going to draw it because it looks really, really messy. So A, that's AB, right? So what's A? So now we have to take AD. AD is 4I, which I'm going to draw right now. 1, 2, so that's 1, 2, 3, 4, minus J. So it's going to be like down here, right? And then minus 2K. So it's going to be 1, 1, 2. So it's going to be like right, I don't know, right. So down here, so like down here. So that's our second vector. Now, how do we know where the C is going to be? Right, we have our A, AB, minus I plus 2J plus 3K, and AD, 4I minus J minus 2K. How do we know where the C is going to be? We know where the C is going to be because of the parallelogram, right? So if we add like this, an extra copy, I'm going to change the pen. If we add an extra copy of the AB onto the AD, or an extra copy of AD into AB, what we're going to get is a parallelogram right here. I don't know if you can visualize that. It's a little hard to visualize, but we can add those together. And what will this give us? This will give us AC. Give us AC, right? AB plus AD is equal to AC. And we'll also, because we have A at the origin, we'll know the coordinates of C as well, which is great. So what will this give us? It will give us 3I plus J plus K. 3I plus J plus K? Yeah. So 3I plus J plus K. So it's actually supposed to be somewhere here, but I suck at drawing. I'm sorry. So this is our AC. And what we have to do is find the area of the parallelogram. How do we find the area of a parallelogram? How do we find the area of a parallelogram? Well, to find the area of a parallelogram, all you have to do is dot product, right? So dot product. So that will give you 1, minus 1, 2, 3, dot product with 4, minus 1 minus 2, which gives you minus 1 times 4 minus 2, and minus 6, which will give you minus 12, and I don't know if that's actually correct or not. Wait, area of the parallelogram. Area of the parallelogram. I don't know if it's this or cross product. I just forgot. I don't know if this is how you do it or if you have to do cross products. I'm gonna determine if ABC is acute or obtuse by using a suitable scalar product of two vectors. What is a suitable scalar? Oh, it's a. Oh, okay. I know what a suitable scalar product of two vectors is. So this is AC, right? So what we have to find is BC. That's what we're gonna have to find. This is A. That's B. That's D. This is C. We're gonna have to find BC. How do we find BC? Take AC, and then we have to subtract AB. AC, subtract AB, that'll give you BC, right? So AB, our AB is this, and then subtract it to AC, which if you notice, AB subtract AC is going to be AB subtract AC is going to be minus 4I plus J. Wait, give me a minute. AB subtract. No, that's not right. That's not right. Because this is a parallelogram. AD is equal to BC. There you go. I'm sorry. I'm just kind of not in it today. AD is equal to BC because it's a parallelogram. So next we have this dot product already, and our products are supposed to be our thing is supposed to be AB, like this, dot I don't know what I'm doing. AB dot BC is supposed to be equal to the length of AB times the length of BC times cosine theta. So suitable scalar product of two vectors, they mean the dot product, which is minus 12 equal to AB BC. What's the magnitude of AB? Well, that's minus 1. So that's all of them squared and take the square root. So squared minus, that'll give you square root of 14. So that's equal to the square root of 14. And AD equal BC, so squared, add them together, that'll give you square root of 21. Right? Squared, 16 plus 4 plus 1. Yeah, okay. And that's cosine theta. Right? And we're gonna put them all to the other side. We'll get minus 12 over the square root of 14 times 21 is a big number. It's 294. That's a really big number. That's like 17 or something. So by that, you can now determine that the angle ABC is obtuse. That's obtuse. Now, I actually don't know how to find the area of the parallelogram. I think you have to do a cross product. I think you're going to have to do a cross product. I'm going to do a cross product. A cross product is not going to be fun at all, but I'm going to do it. AB cross AD is equal to what do we have to find for AB plus AD for cross product? So that's going to be equal to I hat, J hat, K hat, like this. Minus 1, 2, 3, 4, minus 1, minus 2. And this is going to give us, so positive first, and then minus, and then positive. So 2 times, so we have to This is kind of a weird 3 by 3 thing where you find the determinant of a 3 by 3 matrix. So 2 times minus 2 plus 3 times minus 1 is minus 7. So you get minus 7i. And then j is minus this time, so minus 1 times minus 2 minus 3 times 4 is minus 1 times minus 2 is 2, minus 3 times 4 is minus 12, so minus 10, minus 10 j, and then plus, so first of all it's plus minus 7i minus 10j plus, so you kind of alternate the signs, so you get 1 minus 8, that's minus 7k. And so minus 7i plus 10j minus 7k is supposed to be whenever, if I draw this as a plane, it's supposed to be the thing that's perpendicular to that plane. So let me actually draw it. Minus 7i will probably be like somewhere there, and minus 10j will probably be somewhere here, and minus 7k would probably be somewhere like really far, like here. So what you're gonna get is we're gonna get a vector that goes like this, which is totally definitely perpendicular, or well, like this, which is definitely perpendicular to the plane, right? No, it's not definitely, but it looks perpendicular to the plane. And what you're gonna get? You're gonna need the parallelogram area. So that's just the magnitude, which gives us a square root of 198, and that is our answer for A. Square root 198. Next, consider these two graphs where B is belongs to the Z. B belongs to the set of natural numbers. So we have this right here, and then consider graphs, so y equals x, and y equals minus x plus b. So whatever this b is right here, that's b. Right, that's sketch the graphs on the same set of axes. That's it. But given that the graphs enclose the region of 18 square units right here, we have to find what b is. So that's actually not that hard. What we're gonna have to do is these two regions enclose a square. And how do we know? Well, that's a square, right angle, right? And then this is minus x. So what we have is this and this. They're both at, let's say, restrict to y is x is only smaller than 0. We'll have y equals minus x and y equals x, and m1 m2 is equal to minus 1 times 1, which is equal to minus 1. Therefore x equals 0, or at interval x is smaller than 0. Y, I say this is y1 and this is y2. So at interval smaller than 0, y1 is perpendicular to y2. And we can prove the same for the other side, but I'm not going to do that. So what we're going to have to do is, since it's 18 square units, we'll have to find something squared that is equal to 18. So let's say x squared is equal to 18, and so x is equal to square root of 18, which is equal to 3 square root 2. So now we know that the lengths have to be 3 square root 2 where they meet, right? The lengths have to be 3 square root 3 times 3 square root 2 where they meet, in order to have that area of 18 square units. So how are we gonna get 3 square root 2? Well, it's actually not that hard, because this is a square, and since this is x, y equals x, it goes up in a 45-degree angle. So we could actually just drop a bunch of heights down. We'd be fine. to believe that these can just be anything, right? These lines, and we have to figure out this. So this is going to be A. Let's say this is A, length A. This is also going to be length A because it's a 45-degree angle, and whenever you drop a line down, you get a 90-degree angle, which gives this also a 45-degree angle, which therefore results in a right isosceles triangle. So we had 2a squared is equal to 3 square root 2. So then we get a squared is equal to 3 square root 2 over 2. Wait, give me a minute. No, it's not 2a. It's a squared plus a squared equals c squared. Okay, a squared 2a squared is equal to 3 squared 2 squared. So then you get 2a squared is equal to 18. A squared 9. And a is 3. So this will be 3, this will be 3. And since we have another triangle up here, whenever we have our correct b, we will have another up here with 3 and 3 because they're symmetrical. Our b is equal to 6. Next. This is a challenging test. An arithmetic sequence is u1 equal 1, common difference d0. Given that those are the first three terms of a geometric sequence, u2, u3, and u6, find the value of d. Find the common difference. That is a little bit challenging. Okay, so what I'm thinking is u1 is equal to 1, right? So u2, u3, and u6. So it's u2 times k equals u3. u2 you have to times k equal u3. And then u3 times k is equal to u6. u2 plus, let's say L is equal to u3. But u3, you have to add 3L for it to be equal to u6. So basically, what I'm thinking is u3 over u2 is equal to u3 minus u2, and u6 over u3 is equal to wait, this actually no, that's flawed logic. That's not correct. u2, u3, and u6 are the first terms of an economic geometric sequence. u2 add something gets you u3, u3 add something gets you u6. Well, multiplied by something, but you have to multiply it 3 more times. Okay, so what I'm thinking is 3, d equals 3, and the justification for why d equals 3 is it's not right. I was thinking that nope, that's not right either. u1 equal 1. u1 equal u2 times k equal u3, u3 times k equal u6. So u2 times k squared is equal to u6, whereas u2 plus 4l is equal to u6. They're really different. They're very, very different types of So we're gonna do, that means u2 times k, u2 times k squared is equal to u2 plus 4l. So we can deduce in, wait, let me see. We can deduce in this case that u2 is going to be equal to, if you take this minus 1, you'll have 4l over k squared minus 1. 4l over k squared minus 1. Now let's take u3 scenario. u2 times k is equal to u2 plus l. So if you do this, you'll have u2 is also equal to l over k minus 1. I don't know if that solves anything or not. Let's try. L over k minus 1 is equal to 4l over k squared minus 1. So what we're going to get is we're going to get k plus 1. 4l over k plus 1 is equal to l. And then we're, wait, this might be a miracle. We're going to get 1 is equal to 4 over k plus 1. Which means k plus 1 is equal to 4, which means k is equal to 3. So yes, our geometric sequence is going to be 3. And now we can plug it in to solve for L. So 3 squared minus 1. This is I don't know, I just did something and it worked. 3 minus 1, that's 2, so L over 2 is going to be 4L over 8, and that's obvious though. That's obvious. That doesn't solve anything. 3, u2 is equal to L over 2. 4L over k squared, so that's L over 2 as well. But we have k equal 3, which is great. We know that u2 times 3 is equal to u3, and u3 times 3 is equal to u6. Okay, but times 3 of what is the real question. Times 3 of what? Okay, let me tackle this. Let me go back to the drawing board basically. So we have these. I'll keep these equations in the back of my mind, just in case. We have 4. Actually, we have u1. So we have 1 plus k gives you u2. That's another information right there. 1 plus k equal u2. And u2, we already have it in terms of k and l, right? I think. Oh, no, not 1 plus k, 1 plus l. Is equal to l over k minus 1. And that, we already know 1 plus l, that looks like an e. 1 plus l, this might work, is equal to l over 3 minus 1, l over 2. So 2 plus 2l equal l. So 2 equals 2 equals minus l. So l is equal to minus 2. And that's our answer. D equals minus 2. I didn't use D because I don't know why I didn't use D. I was just kind of dumb. D equals minus 2. Holy crap! I actually did that. How many minutes do I actually get for this? I get 2 hours. I don't get 1 hour. I get 2. I'm sorry. UN. Given the value that UN is equal to minus 15, So if un is equal to minus 50, okay, I'm gonna keep this. Working. So un is minus 15. So what's minus 15? We have 1, minus 1, minus 3, minus 5, minus 4. Minus 9 is u6. So n is going to be 9. So n is 9. So we want to determine the sum from r equal 1 to 9 of r, which is just 1 minus 3. No, I mean 1 minus 1 minus 3 minus 5 minus 7 minus 9 minus 11 minus 13 minus 15, which turns out to be minus 63, because this is a non-existent and this is just minus, and then add all of them together, which gives you 63, which is 9 times 7. So that is your answer. That was a lot harder than it was supposed to be. Use the method mathematical induction. Prove that this is equal to prove that this is divisible by 9 for n belonging to the positive integers. So let's prove the base case. 4n plus 15n minus 1 is divisible by 9. Let's prove this base case, right? So we're gonna have this is equal to n equals 1 to n equal 1. So that means 4 plus 15 minus 1 is divisible by 9, which is equal to 18. 18 divided by 9 is 2, and 2 belongs to the set of positive integers, so that is correct. Now we have the induction step. We're going to assume that 4 to the n plus, we're going to assume that 4 to the n plus 15n minus 1 is divisible by 9 for all n. Now we're going to have to prove that 4n plus 1 plus 15 times n plus 1 minus 1 is divisible by 9. So what's going to have to happen? We're going to have to algebraically prove that it's divisible by 9. So let's do it. This is 4 to the n times 4, and then this is equal to plus 15n plus 15 minus 1, and right? Wait, no, 15 for the n times 4. Yeah, okay. So this is gonna give us well, let's do 4 to the n times 4 plus 15n plus 14. 4 to the n times 4. Actually, I have an idea. We're gonna do this is my idea. We're gonna do 4 to the n times 3 plus 4 to the n. So it's gonna be 4 to the n times 3. Right? Yeah. Plus 15n. No, 4 to the n times 3 plus 15, because I don't want the 15, and then plus 4 to the n plus 15n plus minus 1. So our objective now, I guess you could say, is to prove that this is going to be divisible by divisible by 9, right? Which this is actually a little bit tough. Because we already proved that this is divisible by 9. Now we just need to prove this is divisible by 9 as well. So I think I'm gonna do a second proof. So this is gonna be 4n times 3 plus 15, which is 3 times 4n plus 5. And I know that this is divisible by 3. So 4n plus 5 has to be divisible by 3 if 4n plus 15n minus 1 is divisible by 9. We're going to use a second induction. We're going to use a second induction. This is I don't think this is allowed, but it doesn't matter because I'm going to get all the points in this test anyways. So this is going to be 4 to the n. We're gonna do the base case, right? So 1, so n equals 1. We're gonna get 9, and 9 is divisible by 3. That's correct. Now we're gonna assume 4n plus 5 is divisible by 3. We're gonna prove 4n plus 1 plus 5 is divisible by 3. That'll give us 4n times 4 plus 5 is divisible by 3. And this is a little bit harder than I thought it was going to be. 4 squared plus 5. Okay, so 4 to the n plus 5 is divisible by 3. 4 to the n plus 4 to the n times 4 plus 5. 4 to the n is hard. Wait, I think I might be able to do it. I think I might be able to do it. Let's make this smaller right here. Make this smaller. Make this smaller. Make this smaller. Induction proofs they're quite hard. So yep, I made it a little bit smaller now. So now what we want is for this to be divisible. So we're gonna have 4 to the n times 3 plus 4 to the n plus 5 is divisible by 3. But we already know that this 4 to the n plus 5 part is divisible by 3. Already divisible by 3 since we said it, right? Assume that 4 to the n plus 5 is divisible by 3. I forgot to write assume. And then 4 to the n divisible by 3. This is obviously divisible by 3 because it's 4 to the n times 3. So obviously going to be divisible by 3. So there you go. QED, we've proven that it is divisible by 3. And we've also, because we've proven this is divisible by 3, we've also proven that this is going to be divisible by 3. And therefore this is divisible by 9. And the method is proven. Question 9, find arcsine of dx. So what I'm actually going to do is, I forgot what arcsine is. I forgot what like the actual answer is, because it would be integral. So I'm actually going to do it in terms of theta. So let's say arcsine x equals theta. That's my substitution. So sine x will give me what else? What arcsine of x equals theta, so x will give me sine theta. And dx will then give me cosine theta. I think that works, right? Wait. Dx gives me cosine. No. Wait. What? X equals cosine theta d theta. There you go. I'm sorry, I forgot the d theta. So this will actually give you the integral from sine theta, cosine theta, d theta right? And then we can make a second substitution. Sine theta equal u. Cosine theta is equal to du. Or cosine theta d theta equal du. Which will give us this u squared over 2. No, not yet. U du, which is equal to u squared over 2 plus c. And u is sine, so sine squared of theta over 2 plus c. Right, and then sine of theta is x. So this will give you x squared over 2 plus c. And I really do not think that is right. I don't think that's right at all. Not even close. I don't think that's right at all. How is it that simple? It can't be that simple. It's arc sine x. Arc sine x equals theta, x equals sine theta, dx equals cosine theta d theta. There might be like a flaw that I just couldn't, It's just 5 points. We're 5 points. I might go back to this question. I don't think that it shouldn't be the correct answer. It shouldn't be as easy as x squared over 2 plus c. Maybe I did the substitution wrong. Okay, I'm just gonna go to the next question. So continuous random variable x has a probability density function. I don't know what this is. Given by this, find the value of k. Wait. Is it basically saying that the integral from 0 to 6, since it's a probability density function, the integral of 0 to 6 k sine of pi over 6x, I think it's basically saying that this has to equal 1, because probability density, the probabilities have to add up all to 1. So if I take k out, I'll get 1 over k, and then I can erase this x right here, then I can integrate. So what will this give me? Sine pi over 6x. First of all, I actually have to then put everything over 1 over 6, so it will be 6 over x, or 6 over pi. So our integral will be 6 over pi cosine, or minus 6 over pi cosine of pi over 6x plus c. And this is 1 over k, right? And this is from 0 to 6, gotta evaluate from 0 to 6. So if you take 6 in here, you'll have cosine of pi. What's cosine of pi? What's cosine of pi? It's minus 1, right? Minus 1, so you'll get 6 over pi minus 0. So 0 is just cosine of 0, which is positive 1. So what? Wait. Wait, there's something wrong with this. Okay, there's no plus c, first of all, because it's a definite function. But there's something wrong with this, because, 0, and this is, c, right? That is 6. So 6, and then minus cosine pi is positive, right? No, negative. It's negative. Minus minus. Yeah, minus 6 over pi, which is 12 over pi, is equal to 1 over k. So k is equal to pi over 12. There you go. So k is pi over 12. By considering the graph of f, write down mean of x, median of x, and mode of x. So the mean of, wait, what? Oh, we're gonna have to write down the value of the mean of x. I think they're all going to be the same. They're all the same. But we have to find the maximum value. And this looks like a symmetrical function because it's a sinusoid. But what's its period? Its period is pi over 6, so its period is going to be, take that, you flip it the other way, you'll get, I think it's going to be the same period. You take that, you flip it all the way, you get like 12. So yeah, that the period is 12. So k equals pi over 12. Gives you that whole thing. Find the value of k. By considering the graph of f, write down the median of x. So we can put 3 in here, 3 pi. We have sine of pi over 2. So sine of pi over 2 will give you the value of, sine of pi over 2 gives you the value of 1. And then 1, so the mean of x should be pi over 12. Should it? It's very weird. Pi over 12 sine pi over 6. Wait, no. Not pi over 12, 0. Cosine of 3 pi over 6 times pi over 12. Wait, 0? Three pi over 6 is halfway through, right? Yeah, it is. Sine of pi over 6. If I put 0 in there. Oh, we're gonna have to actually find like the mean. I forgot how to find the weighted average. I seriously forgot how to find the weighted average. I forgot how to find the weighted average. Show that P0x2 is smaller than 1/4. Or it is equal to 1/4. This is not hard to show. We just need to do this, basically C. So this is just 0 to 2 of the sines pi over 6x, and we already have pi over 12. So that's equal to pi over 12 times minus 6 over pi cosine pi over 6x, evaluated at 0 to 2. That gives you minus 1/2 cosine pi over 6x, evaluated from 0 to 2. 2 over 6 is 2 pi over 6. 2 pi over 6 is pi over 3, which is a cosine value of 1/2. That gives you minus 1/4. Cosine value is pi over 3, 1/2, minus 1/4. And then that's minus cosine 0, that's 1. So minus 1/2. That will give you 1/4. And that's the answer. That's easy. Really, really easy. State the interquartile range. We could do the same for 4 to 6, since sine x is symmetrical. Along that line, sine x is symmetrical, so the interquartile range of x, this interquartile range thing, is 2 to 4. So 2 interquartile range, IQR, is 2 to 4. And calculate x is smaller than or equal to 4 Actually, I think I'm gonna stop it today. I'm gonna stop for today. Right, it's been 1 hour, so we're gonna spend the next hour later. Bye. Welcome to the second part of this IB exam. Me trying to pass this exam, which is not fun at all, but we're just gonna have to try. We're gonna have to try to pass it anyways. So we are going to try to tackle this part now, because in fact I don't know what this is. I don't know what the line in the middle means, so I don't think I'm gonna be able to solve it. I think it means like it's some kind of condition, but I just don't know what it means. Like, is it x? Is it x is smaller than or equal to 4, or x is bigger than or equal to 3, but the part between 4 and 3 doesn't count? I'm not sure, but I could try to do that using the integral formula, but I'm just not gonna do it. So for the mean of x right here, what do I do for the mean of x? I have to actually use the weighted average formula, which I don't know. Yeah, that's what I don't know, and I think the way to use this formula is actually like this. You take the integral, you put f of x in, right? And then you put like another function that says the average, and then you divide that by the integral of f of x. Actually, no, that's wrong. That's not what I'm supposed to do. You're supposed to put f of x and then some kind of average function, let's say h of x, and then you divide it by the integral of h of x, like this, which I don't know how to do. I really don't. Well, the integral of f of x is, I've already worked it out. It's this, whatever this is, it's minus 1/2 cosine pi over 6x. So what's the function? I think it's just 1. I'm not sure, because everything's already, it's already probability density. It's already like I'm actually not sure. I'm not sure. I'll just skip this. Skip. The median of x. The median of x is the average value. Not the average value. The the answer where whatever limits that I have from 0 to a. So the limit from 0 to a. So the limits of this integral from 0 to a, whatever it equals has to equal to 1/2. And so the median of x is actually just, you put this as 1/2, which will get you it will get you the answer of 1. So if you put x halfway through, you'll get 3 pi over 6, which is like right here, and 3 pi over 6 is 1/2 pi over 2, so it's pi over 12. I think that's the median. And then the mode of x is going to be, the mode of x, actually, the mode of x is pi over 12. The median of x so okay, wait. So the interquartile range of x is between wait. I don't know what I'm doing. The mode of x is at. Okay, the median of x. The mode of x is at x equals 3, and f of x is equal to pi over 12. But the median of x I think the median of x is just at x equals 2. And f of x would be equal to, so if you put 2 pi over 6, that gives you pi over 3. Sine of pi over 3 is square root of 3 over 2, which will just give you a square root of 3 pi over 24. I don't know if I did that correct or not, but I don't know this probability function stuff, so it's just my best guess, right? Question 11. Okay, easy enough. Express x squared plus 3x plus 2 in this form. So what you will get is you're going to get x squared plus 3x plus 2. Take this, divide by 2, and square it. You'll get 9 over 4. So what will happen is you will have this x plus 3 over 2, and you can square all of that, and then you can plus 9 over 4. So you have to minus 9 over 4. So in fact, I'll put a minus right here, and then plus 2. So this will get you 9x plus 3 over 2 squared minus 1 over 4. H is 3 over 2 and k is minus 1 over 4. Okay, factorize this. This is easy enough. Just x plus 2, x plus 1. No need to show work. So consider this function where this rational function. Sketch the graph of x, indicating on it the equations of the asymptotes, the coordinates of the y-intercept, and local max. Okay, let's go. We're gonna have this. This is a really easy algebra question. I can do this. So we have x is not equal to minus 2. It literally says minus 2 and minus 1 here. So we could just put that there, and then that there, roughly, right? So this is equal to x equals 2. This is x equals, minus 2, and x equals minus 1 right here. And so what we have to do is we're going to have to take the limit to each side, to the left and to the right. And I might need to leave now because my parents just came home. Okay, I'm gonna go back to this quiz later. Okay, let's start this. We have 1 over x squared plus 3x plus 2, which is 1 over x plus 2, x plus 1, as we've described, as we've seen. 1 over x plus 2, x plus 1. So when is this positive? This is positive whenever the x's are whenever both of them are negative or both of them are positive. So basically, both of them are positive basically at this time right here, and the y-intercept is 0 whenever you put 0 here. So the y-intercept is 1/2. So we gotta put this right here. So that is 0, 1/2. Gotta put that, and then we have to put the graph like this, going there like this. In fact, I'll probably put it in a different color, right? And then what we gotta do is we gotta put they're negative actually in the middle of x plus 2 and x plus 1. And we have to find something called the local maximum, and the local maximum is found by a method called differentiation. So we're going to differentiate this function, or derive, and we're going to take the derivative of 1 over x plus 2, x plus 1. In fact, before I do that, I'm just going to do this first. Sketch the other part of the function. And so now we can do it. We can do our x plus 2, x plus 1 will give you, this will actually, you gotta use the quotient rule. So derivative of the first function on the top function, not the derivative of the bottom. So derivative of 1 is 0, and it doesn't matter what the bottom is. So basically we have, if it's f over g, if it's a derivative of f over g, then it's f prime g minus fg prime over g squared. And so we have f prime, which is 0, so we have 0, and then minus fg prime f is just f, so 1, and then g prime is just going to be this x squared plus 3x plus 2, and the derivative of that is just 2x plus 3. And then that's over g squared. So g squared, we actually don't have to care about this because it's going to give us a nasty number, x plus 2 squared, x plus 1 squared. We know those are asymptotes anyways, so what we can just do is set this equal to 0, because when the derivative of 0 is 0 in a continuous function, it goes from either positive to negative. It had to go from positive to negative to reach that 0 in the first place, or negative to positive. So it'll be either maximum or minimum, which is, well, now we have minus 2x plus 3 is equal to 0. So 2x plus 3 is equal to 0. X has to be minus 3 over 2. So if we draw this graph right here, this local maximum here is going to be at x equals minus 3 over 2. And what would that be in y? That would be 1/2 and minus 1/2. So it would be minus 1 over 4. Right? Wait, is it? No, it would not be minus 1 over 4. I'm sorry. It would be, put minus 3 over 2 in here. Minus 3 over 2 plus 2 is 1/2. And that's minus 1/2. So that's minus 1 over 4. So that would actually be minus 4. Minus 4 is our local maximum. Show that this is equal to this. I'll do that right now with simple algebra. I'm eating. X plus 2 over x plus 1, x plus 2 minus x plus 1 over x plus 1, x plus 2, and x plus 2 minus x plus 1 is 1 over x plus 1, x plus 2. And if you expand this, you will get 1 over x squared plus 3x plus 2. And that's that question. Hence, find the value of p if the integral from 0 to 1 of f of x dx is equal to the natural log of p. It's gonna be a little bit tough, but we can take this 1 over x. We know that our integral, first of all, we're gonna calculate this integral from 0 to 1, so 0 to 1 of f of x, which is this 1 over x squared plus 3x plus 2, which is just equal to 1 over x plus 1 over minus 1 over x plus 2 and dx. So this is a partial fraction activity that they basically just gave you the partial fraction for already, so that's fun. That's really cool. You guys know that the derivative of ln x is going to be 1 over x. So the integral of 1 over x is just ln x. Therefore, this, by substitution, x plus 1 equal to u, you can actually just figure out that this is equal to ln of x plus 1 minus ln of x plus 2 dx from 0 to 1. You put 1 in here, you'll get ln 2 minus ln 3, and then minus ln 1, which is 0, minus ln 2. So this will give you the answer of ln 2 minus ln 3 times ln 2 minus ln 3 plus ln 2, which the answer will equal to ln of 4 over 3, so p is 4 over 3. And I actually need another slide to work all of this out. This is actually, there's a lot of stuff involved in here. So we're gonna go to sketch the graph of, I'm gonna take a picture of this and go to the next page because I intended for this to be page 12, but there's no way I'm gonna be able to finish all of this. So we're gonna do this, right? And then we're gonna do this on the next page, which is actually quite hard, this question. So sketch the graph now of y equals f of the absolute value of x. So all the x values will now be a positive x value. So we only really care about the values from here to here. So this is our new graph right here, because all the x values mirror the x values from the other side. So determine the area of the region enclosed by this, the graph of f of f, the absolute value of x, right? This means it's going to be even, because if we take the f of the absolute value of negative x, we're going to get equal to f absolute value of x, which is the same thing. The x-axis and the lines with equations x equals -1 and x equals +1. So we already know our region of x equals like 0, right? We already know our region from 0 to 1 of fx dx. So since it's symmetrical, we can just say that it's going to be, the region is ln 4/3 times 2, and that's the answer. That's it. Because symmetrical even function, and that's going to be the answer. Or you can also say ln of 16/9. That also works. But that's the answer, right? It's not that hard. Next, maximum mark 18. Consider the polynomial x is, no, not x, z to the 5th minus 10z squared plus 15z minus 6z belongs to complex numbers. Write down the sum and the product of the roots of p of z equals 0. And show that z minus 1 is a factor of p of z. So in fact, I actually kind of want to do this first. Looks easier. So show that z minus 1 is a factor of p of z. First of all, we can divide, or we can just put 1 in and tell that it's equal to 0, right? I actually divide because that's a better way for me to decide, and I'm going to use synthetic division to do that. So this is synthetic division right here, and then we have our factor, which is 1. I'm going to put 1 here, 0, no, sorry, 1, and then 1, 1, because there's nothing adding, 1, 1, 1 minus 9, and then take minus 9 in, you get 6, and then 6, 0. So this will give me x to the 4th, or z to the 4th, minus 1z to the 3rd, or plus z to the 3rd, plus z squared, minus 9z plus 6 equals 0. And this does not help me with the write down the sum and the product of the roots of p of z equals 0. Does not help me at all. I can tell you though that the product of the roots is 6. Right? Product is 6. Because what happens when you have this 5th degree polynomial thing is we're going to get x minus a times x minus b times x minus c times x minus d times x minus e, and whenever you multiply them all together, because there's 5 complex roots, because that's the fundamental theorem of algebra, you're going to get a bunch of crap minus 6, right? You're going to get a bunch, right? Okay, so I'm going to write that down right now. So if you put z minus a, z minus b, z minus c, z minus d, z minus e equals 0. You're going to expand this, right? Z squared minus 2a and az minus bz right? And then this is just gonna be a mess. Minus bz plus ab, and then you're gonna multiply this with z minus c, and then it's gonna spiral into confusion. But at the end, you're gonna get minus a b c d e at the end, and that's gonna be your term that you a b c d e is the product of the roots, so that's 0. And in fact, the sum of the roots is going to be the one that's just after z. So the sum of the roots is 0. And I could try to spend like 20 minutes expanding this function out so you could see that the sum of the roots is 0, but I'm not going to do that. So the polynomial can be written in the form of z minus 1 to the third power z squared plus bz plus c. So if we take this form right here, if we take this and then we continue doing the synthetic division twice, we're gonna get there. So this is gonna be 1, 1, 2, 2, 3, 3, minus 6, minus 6, 0. And then we're gonna do the synthetic division again. So 1, 1, 3, 3, 6, 6, 0, 0, 0. So what we're gonna get is x squared, or z squared, plus 3z plus 6. And therefore b equal 3, and z and c equals 6. And we can we want to find the complex roots of p of z equals 0. So what we can do is we can solve this for equal to 0, and then we would get from the expansion, we would get z from the completing the square, we would get z 3 over 2 squared like this, and then plus 15 over 4, and what we will get is the square root of minus 15 over we will get plus or minus square root of minus 15 over 4, and then 3 minus 3 over 2. So our complex roots are equal to minus 3 over 2 plus or minus I square root of 15 over 2. That's our complex roots. Okay. Consider this function again. Think the same function, but this is only x belongs to the real numbers. So show that the graph of y equals qx is concave up, or x is higher than 1. To prove concavity up, you have to have the second derivative equal to a positive number. So for x is higher than 1, you're gonna first have to prove that it's going to be positive for 1, and it's going to be positive for 1 for every number higher than 1. So let's do that. Q prime x equals 5x to the 4th minus 20x plus 15, and q double prime x will equal to 20x to the 3rd minus 20. And this is 20x to the 3rd minus 1. And this is 20x, this is 20x to the 3rd minus 1, so 20 x squared, x squared minus 2x, or no, x squared minus x plus 1, x plus 1. Right? Is that the correct? X cubed minus x squared plus x squared minus x plus x. Yeah, okay. So that's our, no, this is our x plus 1. This is supposed to be x minus 1. So it'll be x squared plus 2x plus 1. No, not 2x, I'm sorry. Plus x plus 1. And then x minus 1. So whenever you multiply it out, it will be x cubed minus 1. So we gotta prove that this is positive. for x is higher than 1. So how do we prove that this is positive? Well, when x equal 1, when x equal 1, this equals 0. So q double prime x equals 0. And so that's basically the point where it goes flat. There's a point of inflection. This is a point of inflection. And when x is higher than 1, then q prime of x is higher than 0, so it's concave up. I don't know if that's enough justification. I really don't. So that's for that question. And sketch the graph. So we're going to do that here. Sketch the graph of y equal qx, showing clearly any intercepts with the axes. Okay. There you go. Okay, so we know that x equal qx is already x minus 1 to the third power, x minus 1 to the third power, right? Because, yeah, x minus 1 to the third power, x squared plus 3x plus 6. So this is our graph that we have to work with. So this is actually something called multiplicity, which is a little bit out of a lot of people's depth. But multiplicity means close to that point's behavior, close to that 0, you're going to get the same behavior as a regular graph of that same like parent function. So this would be x cubed. So it will look the same as x cubed because you have the function like that. So any intercept with the axes, first of all, you can put 0 in here, and the answer that you will get whenever you put 0 in here is minus 6. So q of x, the y-intercept is minus 6. So y-intercept is minus 6. We can check for concavity, which we probably should, but we have our concavity equation, which is 20. So q double prime x equal 20 x cubed minus 1, and we have our q, just regular prime x, and that's equal to 5x to the 4th minus 20x plus 15. This won't really help us much, as much as this. So we have our intercepts. Our intercepts are 1, which is right here. And we can access, what do you call it? Not access, but assess for n behavior as well. So n behavior is actually, it's going to be positive here and negative here, because when you put a massive negative number, it's going to get more massively negative because of the x to the 5th power not being positive, basically. So what you're actually going to get is, you're going to get this sort of stuff because of the behavior of the x cubed, right? And then the left side is going to be a little bit tougher. It's not going to cross this axis. It won't. So we're going to have to assess for concavity on the other side as well. Which means we have to solve x squared plus x plus 1 equals 0. Is there a solution to this? There might be. I don't think there is. I don't. Yeah, I don't think there's a solution to this. Because minus 4ac gives you minus 3. So I think that's going to have to be it. I think that's the only solution. This is 1, 0. And then there's probably some weird things happening right here that I don't know. But I know that it's a negative concavity here, so it's just going to go down like this. It's not a positive, what, is it a positive concavity at 0? No, it's not, it's a negative. It's a negative concavity, so it's supposed to be like, like this, kind of, that kind of stuff. So let me actually fix the graph. So it's supposed to be even more down, even quicker. And that's it. That's the test. I'm finished. Let's check the answers. This mathematics higher level stuff it is quite hard. First question. Wait, let me see. Follow through marks, I don't care. Misread, I don't care. Really. I don't want to read any of this. So, we have to, okay, so, basically these marks are really, like, close. So, first of all, what it says is, I have to get, okay, I think the thing is deformed, yeah, okay. So first of all, what it says is I have to get a I'm gonna put another window capture to capture this Google page. Give me a minute. Where is it? Search. No, that's not it. That's definitely not it. Chrome, right there. Okay, right here. So what I'm gonna do is I'm actually gonna have to make this smaller, or well, make it so that it fits. I don't know how to make it so that it fits. So basically, I'm gonna erase all of these. Erase. Okay, so what I should, yeah, I'm gonna do this with my screens because the screens are kind of just, they take over the space too much. Okay, I'll try to make it work. Like, this is so scuffed. I'll try to make it work like this. There you go. So we have our section A right here. Question 1. We have log base 2, so we have to collecting at least 2 log terms. So we have to show that it's collected like this. So log 2 x over 5 like this. So we showed that right here. Obtaining a correct solution equation without logs. So x over 5 equal 12, or x over 15 equal 12. So x over 5 equal 12 right here. We did do that. And x over 15 equal 2 squared. What? I don't know about that, but we did get the x over 5 equal 12. So that's valid. And we got x equals 60. So that's 4 points. Or I'm actually gonna mark it in a different color because I think I'm gonna lose a lot of points. Okay, so A is z1 equals 2 cis pi over 3, and z2 equal square root of 2 cis pi over 4. So I didn't actually do that. So I lost 2 points automatically for not doing that. Award A1, A0 for correct moduli and arguments found but not written in mod arc form. So this mod arc form thing has to be written in cis form, or cosine I sine. So the modulus of w is actually square root 2, not 2. So that's wrong. And the argument of w is pi over 12, which is, I put it in this form, but I didn't put it as pi over 12, so I didn't get any points for this. Find the smallest possible integer n such that wn is a real number. I didn't even do that question. So I lost 2 points for that as well. That's fantastic. So I didn't get any points for this, 0. Question 3, solve this equation. So use of sec squared x equal tan x plus 1. I did do that. Tan x2 squared x, so that's methodology, so that's gonna give me 1 as well. Tan x equals minus 1, which I actually didn't put down. I should have put that down, but I'm gonna give myself the point for that because that's really obvious. and x is equal to those two questions. So this gives me the full 5 points. Next is total number of arrangements is 7 factorial, which I did show, and number of ways for girls and boys to sit together is 3 factorial, 4 factorial times 2, and then the probability is actually the top divided by the bottom, not the number of combinations. So basically I just did this point wrong. So basically what I get is I get 2 out of 5, I think. 3 out of 5, yeah, 2 out of 5 is what I get. So 2 points for this. 2 points. Next, we have AB cross AD. So we actually did have to cross AB and AD, and we did not get the right answer because for some reason I thought it was 7. I thought -4 plus 3 was 7, so I couldn't, method-wise, I got 1 point, but I wasn't able to get the other points because I wasn't able to check my answer. So we could do method 1, AB, AD, and considering the sign of the answer, if it's smaller than 0. So we actually had to consider the sign of the answer, and -12. I didn't even. Okay, I said it was obtuse, and obtuse is wrong. Obtuse is wrong. DAB is obtuse, and ABC is acute, because I was supposed to take BA and BC, not AB and AD. So I basically did the wrong thing, is what I did. So I got 2 points for that. So that's 3 in total out of 7. Number 6, we have this function right here. Graph sketch correctly, condone missing B. So basically, that works. And then B squared over 2, so B equals 6. I didn't actually do that. I did this weird method right here, which I don't know if that actually counts as a point, but I got 4 out of 5 at least. Seven 2, use of UN equal U1 plus N minus 1D. I did not do that at all. I didn't do that at all. Not even close. 1 plus 2D squared equals 1 plus D, 1 plus 5D. Didn't do that at all. But I did ended up getting D equal -2. So I only got 1 point for that. 1 plus N minus 1 times -2 is equal to -15. N equals 9. Okay, I did do that, basically. And then 9 over 2 plus 2 plus 8 times -2, which is, I didn't actually write that out, but I did get that out, so that's 2 points. So I got 3 out of 7 points. Even though I got the exact correct answer, I only got 3 out of 7 points. It's quite brutal. So let Pn be the proposition that is divisible by 9, showing through for n equals 1, which is divisible by 9, so P1 equals true. So you have to consider, yeah, so assume truth. Yeah, I could do that. Consider, now we have k plus 1, so we would be able to get this now, and then, so they didn't do it this, like the 2, they didn't do two steps of. So method 1, k4 times 9k, 9a minus 15k plus 1 is going to give you that, which I didn't do that. And please, one, by the principle of mathematical induction, P of n, I didn't write that down either. So basically what I got for this is 3 out of 6. Attempt at integration by parts, didn't do that at all, so that's just L. No, I didn't get any points for that. Question 10. Attempt to equate integral to 1. I did that. I did do that. So that's correct. And then the correct integral, which I also did that, and k equals 12, so I also did that. So I got all the points for that. Mean 3, median 3, mode 3. I only got 1. I only got 1 correct answer. Except the pi over 12 without the pi over 12 if it's added later. So 1/4. So we did this and we did the integration correct. So that's great. And that's gonna give us all of this, the whole point. And then 2, as graph is symmetrical around the middle value is 3. So I didn't actually write that down. So interquartile range is 2. So from 2 to 4. C1I quartile 1 is equal to 2. Graph is symmetrical to 3. So I actually had to write all of that down. I didn't write any of that down, so I only got actually 1 point for that. So that gets me 1 point. And so 1 point. And then this gets me 4 points, so 5. And this is I got that correct. And then I got this correct for only one of the points. I didn't know this at all, so 0. Next we have 11. So I did do this correct, which is good. And then I did do this correct, which is good. So 2. I got both the points. And then I had to draw like this. Vertical asymptote, local maximum -3/2 -4. I actually did write that down. Horizontal asymptote did not include the horizontal asymptote. So I lost 1 point for that. So I had 4 points total. Show that this is equal to, well, I did. So 1 point, easy. Next, find the value. So P is 4/3. That's correct. 4. And then whenever you have this question, correct shape and symmetry about the y-axis, that is also that is correct. And 2 ln 4/3, correct. So 2 integral 0 to 1 f of x dx, which I actually didn't do that. Which I don't know how I'm supposed to score that, but I only got 1 point then. So final question. Sum 0, product 6. Correct. So 2. Write the sum and the product of 2, 0. So they basically did this thing and accept use of division to show that the remainder is 0. So I got 2 points for that. And then this, by inspection, C equals 6, B equals 3. Oh, they're using by inspection. Or they could also do this, or they could have also done this. So that's the correct answer as well. So that's good that we got 2 points or 5 points for that. That's a lot of points. 5 points. And then they did this, or to complete the square. So award the second M1 to use the quadratic formula or to complete the square. So that's going to be -3/2 plus I-15. Okay, so I got all 3 points for that. That's great. And then this is d squared y dx squared. So for x is higher than 1. Yeah, they basically didn't do anything that's too kind of crazy. So they just basically said that it's correct. Which is M1, 2, 1, R1, so that's 3 points for this. And finally, we have this graph right here, which I only need the concave, I only need the x-intercept at 1, 0, and the y-intercept at -6, and the stationary point of inflection at 1, 0 will correct curvature either side, which is correct. So that is going to be positive. That's going to be 3 on 3. And so that's it. That's the International Baccalaureate Higher Level Test um, attempt. I'm sorry, there's a blender going on right now, so it's gonna be really, really noisy. But my final score is, let me calculate my final score. This is very brutal. Let me just tell you that right now. 4 plus 5, so 9, 11, 14, 14 plus 4, 18, 21, 24, that just doesn't count, 34, uh, 4, so 34, and then we have 40, 45, 47, well, no, not 47, yeah, 47, 48, and then 50, 50, 60, and 66. So that's the final score of my higher level exam, is 66 out of 100. Most of the reasons why I couldn't get a higher score was because my methodology was flawed and wasn't used in the way that you would normally use, like the methods that you would normally use in high school. Because I didn't know how to manipulate the arithmetic and geometric sequences, which actually got me pretty mad for not being able to do that. Also, I couldn't find the integral of arcsine, which is pretty pretty disgusting. But that's gonna be it. If you liked it, press the like button, and if you want me to do more higher level tests, which I probably will, just tell me. Just yeah, tell me in the comments, and I'll see you later. For I don't even know.